A weightlifter lifts a 25 kilogram weight up through a height of 45 centimeters in 2 seconds. What average power did the weightlifter apply to the weight in watts? And it says average power there, but why average? Well, in reality, the weightlifter may have started out faster and then slowed down, or maybe she started out slow and then sped up, right? In that sense, average power, like maybe the power was larger to begin with and then less later on, or the opposite, right? But really, in that sense, the two formulas that we've been presented for power really are kind of like average power formulas. So, anyways, we could either use work per time, but the other formula was power is equal to change in energy per time. But it really, I think it's just a matter of point of view, because we could say, well, it's work done by the weightlifter in the sense of force times displacement, but the force is equal to the weight of the weight, which would be mg. The displacement would be a height, so that'd be mgh, but that's also the change in gravitational potential energy. So really, at the end of the day, what we're doing is we're looking at mgh over a certain amount of time. And given the information that we're given here, we have m is equal to 25 kilograms, h is equal to 45 centimeters, and delta t is equal to 2 seconds. So that's, I think, what's pretty clearly coming from the problem statement. And so the calculation we're going to really do is 25 kilograms times 9.81 meters per second squared. Maybe I want to turn that height into a 0.45 meters so that all the units are in base units. That tends to make things easier. And then divided by 2 seconds. And the units here look complicated, but I can kind of see there's a Newton there times a meter, which would be a joule, and then per second, which is a watt. So I think we're going to get something in watts because of the units that we chose. In particular, not sticking with the centimeters was important to that. So if you run these numbers into the calculator will say it's like 55.18, etc. But maybe 2 digits is enough, so we're just going to say that this is 55 watts. So let's go ahead and check that. And there it is.